Today we're going to talk about the resistance of a wire and the resistance formula. The resistance formula is R equals rho times L over A. R is the resistance, it's measured in ohms. L is the length of the wire, measured in meters. A is the cross-sectional area of the wire. And then rho, which is that little funny looking P thing, is resistivity. It's in omegas times meters, and it's based on whatever the material the wire is made out of. The table of resistivities is on page 4 of your reference table, and it has a few different resistivities of various materials. So find page 4 and find that table before we get started. Now, the area, which is on the bottom, the more area and the more cross-sectional area, the easier it is for the electrons to flow through, which is going to give you a lower R. I want you to picture the tubes, the play place at McDonald's. You know how if the tubes are really, really wide, it's easy to crawl through? Same thing with electrons. So the more cross-sectional area, the easier it is for the electrons to go through, and the lower the resistance. So let's try our first problem. We have an aluminum wire with a length of 20 meters and a cross-sectional area of 3.2 times 10 to the negative 6 meters squared. What's the resistance of the wire? So we're going to use our equation. R equals rho L over A. And what do we know? We know the length of the wire is 20 meters. We know the cross-sectional area is 3.2 times 10 to the minus 6 meters squared. And then we need to know what the resistivity is. So it's aluminum, so we're going to look on our reference table, and it says that aluminum is 2.82 times 10 to the minus 8 ohms times meters. So we are going to plug all of those into our equation. So we have R equals 2.82 times 10 to the negative 8 ohms times meters times 20 meters, all divided by cross-sectional area, which is 3.2 times 10 to the minus 6 meters squared. So we're going to put that into our calculator, and we should get R is equal to 0.176 ohms. Alright, well, let's try it with the game. Now, we're not going to make the game with all of the table this time. We'll just do a short version. If the length is doubled, what happens to R? So we write our equation again, L over A, and it's asking me if I double length. So if I put ones in for everything, like we do with the game, this time I would get 1. But now I'm going to change L. Let's change the ink so you can even see what I'm doing. All over 1, and I get that it's 2 times as big. So now let's try it if the area is doubled. Same equation. So we have our 1 times 1 all over 1 gives me 1. But this time we're changing area, so we're going to do 1 times 1 divided by 2. And I find out that it'll be half as big. I think those are pretty easy. Now we have the last problem we're going to try today. We have gold wire with a length of 10 meters and a radius of 1.76 times 10 to the negative 7th meters. What is its resistance? Now what I'd like you to do is pause this and give it a try, and then look at the answer. For now, what I'm going to do is I'm going to write my equation, and then I'm going to write down my knowns. Got L, 10 meters, a radius of 1.76 times 10 to the minus 7 meters, and what is the resistivity of gold? So I look at my table and I get 2.44 times 10 to the minus 8 ohms times meters. And I'm going to start plugging it in. So I got R equals 2.44 times 10 to the minus 8 ohms times meters times the length of it, all divided by the cross-sectional area. Oh no, I don't have cross-sectional area. I have radius. How do I find cross-sectional area if I have radius? You have to remember your old area formula. Area is pi r squared. So area is going to be pi times 1.76 times 10 to the negative 7th meters. And that's what I'm going to plug in. So I calculated it, and I got area was 9.73 times 10 to the minus 14th meters squared. So I'm going to put that into my equation. And after I calculate it, my answer ends up being R equals 2.5 times 10 to the 6th ohms. And I am all set for today. Have a good day.